Okay. So 20% as a decimal would be what? 0.2. Right? Okay. If 1.00 is a decimal, what would that be as a percent? 100, correct? Okay. If you go and do the GST on your bill at a restaurant, okay, it's 5%. So most people will go times their bill by 0.05 and add it to the total, correct? What's a faster way? 1.05. Why are you multiplying by 1.05? The value plus 5%, because it's what of the value? 105%. So it's 100% of the value plus 5, correct? So that 100, that 1, represents just taking the value and not increasing it nor decreasing it. Yes? So a lot of people freak out about trying to memorize formulas. You don't have to memorize the formula, you need to understand it, and then it's memorized in your head for you. So if we look at the appreciation formula, it's Fi and then 1 plus little I to the n. Little I is the interest in decimal form. So this one, I'm doing 1 plus I, right? So that's increasing because the 1 represents 100%. That means nothing has changed. And the plus I represents the percent it's increasing by. We agree? So if I went 1.10, what would it be increasing by? 1.10, what would it be increasing by? 10%. Yes? If I went 1.25, what would it be increasing by? 25%, because that 1 represents the 100. That represents the no change. We agree? Now there's the depreciation formula, which is 1 minus I. So you're not going to find a 1 in the equation at all. If it's depreciating by 10%, what's going to be in that bracket? 0.9, because the bracket represents what's left. So 90% of the object would be left, correct? If it depreciated by 10%. We agree? We also went over exponential graphs, did we not? And if the b value, the base, this would be your b value, the base of your exponent, correct? If the base of your exponent is greater than 1, the graph is increasing, right? We had an increasing exponential function. If the base was between 0 and 1, which is what's going to happen here when I subtract from 1, it's a decreasing exponential function. We agree? So it makes sense that this formula would be the way it is. Now, F represents the final amount. What you have left at the end. Capital I represents the initial amount, what you started with. Anyone have a guess what N represents? The number of years. Wow, that took you 3 letters to get that guess. You did. I thought I was going to have to write all 5. So 3 was pretty good. Number of years. So let's look at example 1. Example 1. It's always years. So, yeah. So if it was in months, then you'd have to convert it to years. They always give it in years anyways. But if it was months, convert it to years. Okay. So here it says the initial price of a car is $30,000. What is that? Which letter? Capital I. There's a lot of letters being said. Okay. Can we be quiet? It makes the F and the I look different, even though they're the same color, which is black, which is not a colorblind problem. That's okay. All right. The value of the car depreciates. So what does the depreciates tell us we have to do? We have to minus. And it depreciates by 20% per year. This is why N has to be in years, because your percent is in years. You know what I'm saying? So little I, lowercase I, would be 0.20. Okay. if the car is new in 2005, how much will it be worth in 2010? 2005, 2010. What is that? N. So remember in geometric series and sequences, you had to like add 1 to get your N? It was really annoying and stupid because the formula had that -1 in it. You don't have to. Here, the formula doesn't have any weird things, it's just N, right? Last year it was N and then more added on to that exponent. We don't have that. So you just take 2 years, subtract. It's like so nice. Okay, Ben, what don't I have? I do not have F. This is the best thing ever if you do not have F. F is the one that's isolated, correct? You think they're going to give you missing F on a diploma? Probably not. But we do it because they could. They could. They could. The reason why they often don't is they often make you solve for the exponent. Because solving for the exponent, you have to use logs to solve for it. So that's why they often are missing the N, right? That's why. Because that's the thing we're learning to solve for. Because if N is down, if it's like any other N that's on the bottom, you guys know how to do reverse BEDMAS to solve for it, correct? But what we have never had to solve for is N as the exponent except for in grade 11. And then you could just do guess and check till you got that N, was what you kind of got taught in grade 11, instead of converting it to a log because it's not in the curriculum. So we have initial 30,000. 1 minus 0.20 to the 5. So we get 30,000. 0.80 to the 5. Type it in. Go. My goodness. Okay, what is the final amount?
$9,830.40.
And what do we have to make sure we do every single time we have a word problem? Sentence. So the car will be worth $9,830.40 in 2010. All right. This is where it gets into the exponentials and log stuff. Like I know that is because it's an equation, and so it still falls into the exponentials and logs. But this one's going to make us find time, and time is n, and n is in the exponent, and we have an actual algebraic process that can do that. So how long will it take to the nearest tenth of a year? So we're looking for n. For the car to be worth half of its original. So we still need everything else. What is the final? Or sorry, what's the initial? 30,000. What's the final? Because half of that, so it's 15,000. And what's my I? Little I? Lowercase I?
1 or 2.
Yeah, didn't change, correct? Okay. So let's fill it in. We get final, which is 15,000. Equals 30,000. Bracket 0.80 technically to the n. Yes? Okay, I want everyone to look up and listen to me because this is where errors happen. So what a lot of people want to do is they'll take the 30,000 and they'll times it by the 0.8. You cannot do that. 0.8 has an exponent. It cannot be brought together. Not subtract. Close. What do we do? Divide. So guys, can you pay attention? If I ever give you the final and the initial, like the numbers for both of those, you fill in your formula, and then your very first step will be to divide the initial over. If you do that, 99% of you will get the question right. Because that's the error spot what happens. They'll try and put it with that 0.8, okay? So when you have the initial and the final, you slide that over by division, and I guarantee you most people will get this question right. Okay? So that's the first step that you have to always do. So we're going to divide by 30,000. Now, you can put a half, but you don't have to. You can put 0.5. And the reason why it doesn't matter is it's a terminating decimal. They are equivalent, yes? If you put a third and you put 0.33, now you're in trouble because those are not equivalent. 0.33 is 33 out of 100, not a third. Different. But we can put 0.5 because this is actually equivalent. Okay, pencils down, eyes up. Pencils down, eyes up. So, the only way that we could solve this currently is y1, y2. Can't make those common bases, right? Like you can't make 0.8 and 0.5 be the same base, like we did yesterday. So we can't do that. So what they teach you is, if you have 3 pieces of information, currently you have 3 pieces of information, right? We have a 0.5, we have 0.8, and then we have it to the n. 3 pieces of information. And we are missing the exponent. We don't know what it is. When it's like that, the way that you're taught to solve these, and we're going to go ahead a little bit early, because we're going to actually do this as a lesson later, is we can convert this to a log. So the way you solve exponentials, if you can't do common base, you convert it to a log. The way you solve logs, if you can't just solve it as a log, you convert it to an exponential. And that's why these are in the same unit. That's why they're 2 chapters, but we have to do them together, because you kind of need each of them. Okay? So to solve this one algebraically, I can't do common base. I have 3 pieces of information, so I'm going to convert it to a log. Don't pick up a pencil, you're just paying attention. So we are going to go log. We're going to convert it to a log. You're not writing this. I'll give you 4 seconds to write it. It will not take you long anyways. The way to convert to a log, the easiest way that I do it, is I find the base of the exponent first. So which of these numbers is the base of the exponent? This 0.8. That's the base of my exponent. You see that? What you need to remember is the base of your exponent becomes the base of your log. You're like, what the heck's the base of a log? I've never even talked about a log. When you do a log, any type of log, you're going to get log, you're going to get something down here, you're going to get something here beside it, you're going to get it equal to something. Some other something. Yes? There's 3 places that you have to fill in. So hence, when you have an exponent with 3 pieces of information, you can convert it to a log that has 3 spots to fill in. We agree? This bad boy here is the base of your log. It will never change. So just like that's the base of your exponent, that is the base of your log. They are the same. They will always be the same number, so do that. So you pick up your pencil. You're going to go log. You're going to put the base of your exponent as the base of your log, so it's going to go down here. So if this was like a plane, log is above, 0.8 is below. It's like a subscript. Yes? Now, we know there's going to be something beside the log, and we're going to have something equal to something. Yes? The key thing to remember here is once you put the base of the exponent into the base of the log, what I always say to myself is friends don't say friends. So what's friends here currently? 0.8 and n. Those are friends. So will they be friends when I convert? No. So what's going to go beside it? 0.5. And what's it going to get equal to? N. The reason why we converted it to a log is we just took a weird n that was stuck in an exponent that we didn't know how to solve for, and now it's just what it's equal to, right? Now, everyone try this out if you like TI-83, it doesn't work. So every other calculator, let's see if you have it. Some of you do and some of you don't. So press math and arrow up. If you the charging calculators, you have it. So math and arrow up till you see log base. I hope you have it. If you don't, we have different ways you have to do it. TI-83s, you no matter how much you press up, it ain't finding it. So you will have it where you can type it right in. Yeah? Does everyone have that for the most part? Okay, if you have, everyone pay attention because even if you don't have a TI-83, they sometimes write it this way. Is everyone watching? If you have the other calculator, great. But if you don't, the way you're going to type it in, and the way they write it sometimes, is we have 0.8 down here, and we have 0.5 here, right? And you guys are lucky, and you get to write it in that exact way, because that's what it looks like. But if you have a TI-83, or sometimes they write it this way, the way you'll type it in is you're going to put a line through it like this. See how that subscript stays down there? And you log it. This also results in the same thing. So everyone type that in. Log 0.5 divided by log 0.8. You should get the same answer.
Yes.
What is it?
3.106.
So 3.1 years. And then we would write a sentence and we would say it will take 3.1 years for the car to be worth half its original value, right? So if you have the log base button, use it. If you have the fraction button, use it. Thank your parents, because they somehow got it. And also, don't thank your older sibling if you have a TI-83 and they didn't lose it on you. Because they get passed down. Those are the good siblings who don't lose the calculators. Yeah. When I see a TI-83, I'm like, ooh, good siblings who didn't lose calculators, you know? It's been passed down from generation to generation to generation. It is a family heirloom at this point now. And your parents didn't have to pay $180. So that's a good thing. Because they cheat. So if your people don't lose them, that's a good thing. And that isn't really that hard of a different step to just divide by a lot. It's not putting you out. But your parents have to pay another $180. So we're going to call that a win. Okay. Example 2. Let's look at this one. The population of the city was 250,000 on January 1st, 2000, and 310 on January 1st, 2008. So which of those is the initial? So is it increasing or decreasing, guys? It's increasing. We're starting with 250,000. We're going to have a final amount of 310. And what also did they give me? N. Good tech. All right. N equals 8. We agree? Okay. If the growth rate of the city can be modeled by an exponential growth function, the average annual growth rate of the population to the nearest tenth. What are they making me find? Little I. And they want it to the nearest tenth of a percent. Little I is going to come out as a decimal. So what are we going to have to do? Times by 100. Do we round it first, then times by 100? Or times by 100, then round? We only can round in our very last step. Yep? Okay, let's discuss. So, our final is 310,000. Our initial is 250,000. We're increasing, so we do 1 plus I, and our n is 8. We have initial, we have final. What's the first thing I told you to do whenever you have initial and final? Divide it. So we're going to divide 250,000 over. So we get 31 over 25 equals 1 plus I to the 8th. Okay, everyone put their, once they write this down, put your pencils down. I need your brain matter. So once you're done writing this, put your pencils down. Okay, so if something was squared, how would I get rid of it? Square root it. So if something is to the 8th, what could I do? Okay, there's also something else I could do, so let's pay close attention. So what I ultimately want is I want this 8 up here to become a 1, correct? If it's a 1, it goes away. Yes? So instead of taking the 8th root, what could I multiply 8 by to get this to become a 1? 1/8. Don't write this, we're just paying attention. Well, how the heck can I raise that to the power of 1/8 when I know I could just 8th root it? You talked about this yesterday. If I gave you x to the half, what is that the same as a radical? Square root of x to the 1, which is technically the square root of x. Yes? So if we're now going x to the 1/8, what's that the same as? 8th root. So whether I 8th root it or I raise it to the power of 1/8, am I not doing the same thing? One is a radical, one is a rational exponent, but they result in the same answer. So sometimes on the diploma, they'll use their 8th root, sometimes they'll use 1/8. You need to know that those are actually interchangeable. So in grade 10, you're taught mixed and entire radicals, and you're taught how to make a radical into a rational exponent and a rational exponent into a radical. All the grade 10 stuff builds. You need all that material to be able to finish or do anything in 12. Okay? So, you can pick up your pencil. So we have this to the 1/8. I'm not going to turn that to a decimal right now. I'm just going to keep it. So I'm going to go 31 over 25 to the 1/8 equals 1 plus I. I don't know what I'm doing. 1 plus I. What do I have to do to get I by itself? Subtract 1. You're right. So I equals 31 over 25 to the 1/8 minus 1. I want everyone to try and type it into their calculator. Everyone's typing it in. If you have a fraction button, use the fraction button. If you don't have a fraction button, how does your calculator know it's a fraction? You put it in brackets. That's how it knows it's a fraction. Our answer is going to be a decimal. They want a percent. So what are we going to have to do? Times it by 100. And I want it to the nearest tenth. Now remember rounding rules. If they say tenth, how many zeros does a 10 have? 1, so that's 1 decimal place. If they say hundredth, how many zeros does a 100 have? 2, so that's 2 decimal places. So I always say the decimal places are equivalent to how many zeros are in the word they're talking about. Okay? So what do we get? 2.7%, and we have to make sure we have a sentence that would say the average annual growth rate of the population of the city is 2.7%. So you get the population from 250,000 on January 1st, 2000 to 310,000 on January 1st, 2008. Okay, example 3. We're going to talk about A together. So, sometimes they just want you to fill in the equation but not solve anything. So that's like A. So let's read this. In 2002, the population was 160,000, and it's increasing at an annual rate of 4.5% from the percent symbol there. It's missing. Okay. What did they give me? They gave me capital I. What is capital I? 160,000. And we know that's the initial because it says in 2002, that was the population, and it's increasing. So that had to be initial. Correct? It's increasing, so I know I'm going to use a plus sign. I'm going to have something equals something, 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 plus sign. I know that much, right? Okay. Write an equation to represent the population of the city as a function, population P. So we're going to make F equal P. In the years N, so N is N, since 2002. So sometimes we don't know everything. We're just filling in what we do know, right? So we're going to have P equals 160,000. 1 plus what? What is little I? 0.045. To the N. So technically, we will put those together, and we'll go 160,000, bracket 1.045, to the N. Now remember, I said to you, if that B value, that base of the exponent, is greater than 1, that this is increasing. Is it greater than 1? Yeah, we need it to be increasing. It's appreciating, right? And it's greater than 1 by 0.045, so that's how much it's increasing by. All right. Then B says, determine the population in year 2005. So what does that help us get, P or N? N. And how do we get N? 2005 minus 2002, which is 3. So we're going to get P equals 160,000, bracket 1.045 to the 3. Type it in. Okay, what do we get? Now remember with your population, You're going to have to round down because you can't get a part of a person. So what do we get? Sorry, 182 what?
587.
86, Jack, what the heck?
Round down to population. Can't find a part person.
Can't do that.
Same as like a trailer trying to fit 29.2 cows in or 29.8 cows in. You're like, oh, I can fit 30. No, you can't. You get to cut someone's butt off.
50% chance.
I don't. What?
You have 30 cows and 28 chickens. Nobody did it.
Oh, period 3 already did this lots.
See it?
I've done this a lot in period 3.
You know that.
Do see. I haven't got time for this today. I got like a whole 7 minutes. 8 minutes. C. Do C, and then I want you to try example 4. Go. So for this one, we want it to double. So we have 320,000 equals 160,000. Bracket 1 point, I don't remember, 0.45? To the n. We have initial and final, we divide it. And so we get 2 equals 1.045 to the n. I don't know the exponent. I have 3 pieces of information, so I'm allowed to do what? Log it. So I get log base. So I look for the base of my exponent. What's the base of my exponent? So that's going to go down here. What's friends doesn't stay friends. So what's going to go beside my log? 2, and it's going to equal. So what do we get?
16.
It says nearest year. All right. So example 4, you want it to be decreasing, guys. So it says here that NO is the initial population, N of T is the final. It's decreasing by 5%, so 1.0405, and N is N. So we're going to get N of T equals NO 0.95 to the N. Then the next one says, if there's 2,500 fish present in January 2000, how many would you expect in 2005? So then they gave us N and NO. So 5. And that gives us 190 or 1,934 fish. And you'd have to write your sentence that there's 1,934 fish present in January 2005. And then the last one I ask you to reduce to half, so I'm looking for that N. So if I want to reduce to half, it'll be 1,250 equals 2,500, 0.95 to the N. When I know the final and the initial, what do I have to do? Divide the initial over every single time. And I get 0.5 equals 0.95 to the T. My T, what? And my exponent is what's missing. When I'm missing my exponent, I have to convert to a log. Can I convert to a log? How many pieces of information do I have? 3. How many slots does a log have to fill into? 3. So I know I'm going to vote. So I go log base what? What's the base of my exponent? 0.95. What goes beside it? 0.5, and it equals 13.5. Here is 10.